Okay, so now we're looking at tangent, and the tangent graph is unlike the two previous graphs that we have looked at. So we're going to take a closer look. And let's take a, I guess we have to do the exact same thing we did the first time, which is write these down, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Problem is, cosine's the left, sine's the right, what's tangent? So we've done this a number of times, but tangent is sine over cos, which is 0 over 1, which is 0 for this one. This is going to be 1 over 0, the right over the left, which is not possible. Then you're going to have here, the 0 over negative 1. 0 over anything is going to be 0. And then here we have negative 1, so the sine over the cosine, which is 0. Negative 1 over 0 is not possible. So that's what we get. We get 0, not possible, 0, not possible. It's a little bit more difficult than last time we had like 0, 1, 0, negative 1. And so we had a bit of a pattern. But here we got these not possibles, which we don't know what they look like. Then we just have zeros. But one of the ones that I always remember is, well, actually, let's write this down. This is 0. This is 90 degrees, which we write as pi over 2 for radians. This is 180, which we write as pi. 270, which is 3 pi over 2. And then back here at 2 pi. Okay, so if you need to copy that down, you can, or you can just wait till the end of this video. So the one that I really like, if you look back at these, you can find the one right in the middle, that pi over 4. And that one's really good because it's going to be root 2 over 2, root 2 over 2, and you end up getting a tangent of 1. So you end up getting these ones right here, these perfectly halfway in betweens. They're always halfway in between, and they're 1. They're all 1. Except that, whoops, I'll do a different color here. They're not all quite 1 because you actually have to do the cast rule. C-A-S-T. A tangent is positive here and positive here. So that's why it's a positive 1 and a positive 1, but then these ones must be negative. Now, again, you don't have to know all of this stuff. You probably will end up kind of just memorizing it. But you can see here, let's try to draw this. So at 0, when we're at 0, we're at 0. Okay, so 0 radians gives us a height of 0. And then when we're at pi over 4, we're at 1. So, well, here's pi over 2. Half of that would be pi over 4. So that's kind of nice. So at pi over 4, we're at 1. So let's call this 1. Very much like we did the last time. And then at pi over 2, we're at a not possible. So at pi over 2, you have to draw a not possible. Now that's called, and I don't know if we've used this word yet, but it's called a vertical, because it's up and down, asymptote. You don't really say the P. And what these are lines, they're like boundaries, and our drawing is going to get close to the boundary, but it's not going to cross. Okay, so you're at 0, then you're at 1, and then you're at not possible. So here's that pi over 2, we were at a not possible. And then we're at the halfway point. We're back at negative 1. So here's the halfway point, and we're down here at negative 1. And then we're at pi, and we're at 0. So at pi, we're at 0. And then the other halfway point, we're at 1. So the halfway from here to here, the halfway point, we're at 1 again. And then at 3 pi over 2, we're at not possible. So it's another vertical asymptote. And then at the halfway point, we're at negative 1. The halfway point, we're at negative 1. And then here we are at 2 pi, we're back at 0. So you can see that it's kind of, you can see the pattern here. Negative 1, I guess between your two vertical asymptotes, you're at 0. And then the middle between here and the asymptote, you're at negative 1. And between here and the asymptote, you're at positive 1. So I don't know. I just know that there's 1, 2, 3, there's 4 tick boxes. 1, 2, 3, 4. We'll have another one here. And this one's at 1, this is at 0, so then halfway it'll be down here at negative 1. So what you end up getting is you get a curve. It looks kind of like this. It's not attached by a straight line. And you get this line that comes in and gets really, really, really close to the boundary but doesn't cross. And on this way, when you head down, it gets really, really close to the boundary but can never cross. So same thing here. It'll get really close to the boundary but it'll never cross. And here it'll get really close to the boundary but never cross. What's interesting is that it repeats itself between asymptotes, vertical asymptotes. So the period is a lot different. So the period is from pi over 2 to 3 pi over 2. So the gap between 1 pi over 2 and 3 pi over 2. So the period, I don't know where I wrote that here, is the gap, the space between 1 pi over 2 and 3 pi over 2. So what's that jump in between there? Now if you wanted to, you could just go 3 pi over 2 minus 1 pi over 2. You can subtract them. You get 2 pi over 2, which is just pi. So your period is pi. So it repeats itself, which is why if you look at here, from negative pi over 2 to positive pi over 2, you have a half pi and a half pi, because pi cut in half, pi cut in half. So if you have a half pi and you have a half pi, the total you would have is 1 full pi. So the period for tangent is always going to be pi, the basic tangent graph. And so that's when it starts repeating itself. So 0, 1, not possible, negative 1, 0. And now it starts to repeat itself. 1, not possible. So see, after this 0, it went 1, not possible. After this 0, 1, not possible. So it does this, and then it repeats itself to here. So it does in 2, so from 0 to pi, and then from pi to 2 pi. It does two cycles. So, anyways, you're going to end up kind of memorizing how to do this, but what I like to do, and we'll get to this later when we do transformations, is I kind of center myself here. I say pi over 2 to the right, pi over 2 to the left, and draw some vertical asymptotes. And then I always start in the middle and go up 1 and down 1. But you don't need to spend too much time with that because we'll do more of these in the next unit. So what's our maximum? Well, our maximum is infinity. Goes up forever. That's why these arrows. The minimum will be negative infinity. Domain. How far left and how far right? Well, it goes forever to the left. So x is an element of the reals. But we have these problem spots. Like it can't equal pi over 2. And it can't equal 3 pi over 2. And it can't equal negative 1 pi over 2. So it can't equal these. So we have to say, well, x can be anything, but there's a bunch of things that it cannot equal. It can't equal 1 pi over 2. Can't equal 3 pi over 2. What do you think the next one would be if you followed that pattern? 5 pi over 2. 7 pi over 2. ... So you can kind of write it like that for now, that we can say, well, it goes forever to the left and forever to the right, except for we can't equal these boundary points. And I like to put a dot on the left to tell, okay, it goes forever to the left as well. So it goes odd numbers, which is why it would be negative 1 and negative 3, negative 5, all that sort of thing. The range, how far up to down? Well, it'll go from negative infinity to positive infinity. The range is not a problem. It goes down forever and up forever, and there's no problem spots at all. So the vertical asymptotes. The vertical asymptote, I already wrote it there, was at 1 pi over 2 and 3 pi over 2 and then 5 pi over 2. So the vertical asymptotes are there at when x, so I always say cannot equal because it can't equal at that point. 1 pi over 2, 3 pi over 2, 5 pi over 2, ... and there's a ... So you could actually see here, and we'll get to this later, but you can see the gap in between. The distance between 1 and 3 is 2. So every single time I'm adding a 2 pi over 2. Every single time. So from here, 1 plus 2 would be 3. 3 plus 2 would be 5. 5 plus 2 would be 7. So I'm always adding a 2 pi over 2, which actually is, those can cancel out. It's always a pi. So one of the nice ways to write this is x is not allowed to equal pi over 2 plus pi. But you can do that as many times as you want. So they write pi n. N can be any number you want, any whole number like negative 1, negative 2, negative 3, or 1, 2, 3, or even 0. and then n is an element of the integers. So that is another way to write that. Don't get too caught up in that because we'll get to that at another time, but that is something that we'll be doing. A horizontal asymptote is any dotted line that's going horizontal. I don't see any, so we would just say none. And then we've got some x-intercepts. So there's an x-intercept at 0, there's an x-intercept at pi, an x-intercept at 2 pi, so there's a bunch of those. So 0, pi, 2 pi, dot, 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 dot. You can even see here, and it would go forever the other side too. Actually, I should write that down. Dot, 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 dot. So you can see the gap in between is pi. So you can even write x is equal to pi, this one right here, plus as many pi's as you want. So n pi, where n is an element of any integer. So again, don't be worried too much about that. You could just write it as you see it like this, and we'll get into something like that in the next unit. Y-intercept, it crosses the y-axis at 0. So y is equal to 0. That's the height that it crosses. And the amplitude, these do have amplitudes. The amplitude, though, is from the top to the bottom, doesn't make any sense. So we go from this point to this point. So from 1 to 0 is 1. So the amplitude is 1. Again, don't be too stressed about this. I won't ask any weird questions. If anything, I would just ask something like this. Can you just graph tangent? So I wouldn't worry too much about it, but I am mentioning things like this and this to get us to start thinking that, okay, there's going to be some weird pi n, n pi, n is an element of. We're going to be doing lots of things like that in the future. But otherwise, graphing tangent, you're going to have to just kind of rewatch maybe the video again of just me graphing it and how I did that. And that's all you really need to know.